Good morning, students. Now I want to explain about the in organic chemistry about alkanes. First, we discuss about the in organic chemistry alkanes. In hydrocarbons, hydrocarbons classified into different types. One is alkanes, second one is alkenes and alkynes. Alkanes means single bond, either double or triple bond. Next one is aromatic compounds. These are known as a, this is called it as a Benzene ring. These are called as a hydrocarbons. These are the hydrocarbons. In this, we discuss about the alkanes. Now, alkanes, we know alkanes means general formula of this general formula for alkanes is CnH2n plus 2. If n is equal to 1, we call it as a CH4. n is equal to 2, it is known as a C2H6. These are next, n is equal to 3 means C3H8. Methane, this is called it as methane. This is known as a ethane. Alkane, this is known as a propane. These two are differs by how much? Only this is CH2 units. These two also differs by minus CH2 units. Means carbon atomic number is 12 plus 2 means 14. This series is known as a homologous series. Homologous series means these are differ by only CH2 unit. These are only CC single bond is present. That's why this is sigma bond. Sigma bond is very less reactive. Means to dissociate require more amount of energy. That's why these are very less reactive. These are also known as a paraffins. This first we have to remember some of the points about the alkanes. General formula, what are the how the series is good. These are very less reactive. These are also known as a paraffins. Next we discuss about the these shows only chain and CC. Only these show only chain and position isomerism. Not show any other isomerism. Next we discuss about the proper preparation of alkanes. This is very important methods for preparation of alkanes. What are the preparation methods? Preparation of alkanes. How many methods are there for the preparation of alkanes? First I will give the names of the methods of how to prepare the alkanes. Then after that we discuss about the remaining. Next, first one is reduction from alkenes and alkynes undergoes reduction. Reduction means by addition of hydrogen in presence of nickel, platinum or palladium. This is from reduction of this alkenes and alkynes means double or triple bond we get the alkenes. Next, this is also known as a Sabatier-Sanders reaction. This is also known as a Sabatier name reaction. Sabatier-Sanders Sanders reaction. This is also known as a Sabatier-Sanders reaction. In this we can next second method is from alkyl halide. From alkyl halide reduction means or X means fluorine, chlorine, bromine, iodine. X is equal. From alkyl halide, by undergo reduction, they will form the alkane. This is one of the preparation method. One by one, how we get this alkyl halide, we can get. Next, third one is Wurtz reaction. Very, very important. This is the Wurtz reaction. Star mark. Very, very important. By using Wurtz reaction, we can prepare the alkenes. Means that is alkyl halide in presence of sodium plus alkyl halide. We will form the alkane. This is the one of the named reaction. In this also many internally comes many named reactions. Next one is decarboxylation reactions. Next one is decarboxylation reactions. Decarboxylation reaction. Decarboxylation means removal of carbon dioxide. Removal of carbon dioxide from carboxylic acids, known as a decarboxylation reaction. For example, RC double bond OH. By removal of this, we get the alkane RH. In this, they have two methods. One is electrical method. Another one is chemical method. Electrical method, we call it as a coal-based electrolysis. In chemical method, we call it as a soda lime method. These are the two methods used for the preparation of alkanes. By using carboxylic acid, by removing of carbon dioxide, they will form the alkane. These are the two methods. One is electrical method by electrolysis. Next one is soda lime method, chemical method. These two are the important methods for preparation of alkanes. Next, we discuss about the later from mechanisms. Next method is fifth one is from one is from ketones, from aldehydes and ketones, from carbonyl compounds. These are also known as from carbonyl compounds. Carbonyl compounds means aldehydes and ketones. Aldehydes means RC double bond OH. Ketones means RC double bond OR. By using these two, we can prepare the alkanes by reduction of this. These are two types. One is Clemmensen reduction. These are very, very important reactions. Clemmensen reaction. Third one is Wolff-Kishner reduction. One is Clemmensen reduction. Second one is Wolff-Kishner reduction. This is in acidic medium. This is in used basic medium. These two are very, very important. One is from aldehydes and ketones to prepare the alkanes. One is Wolff-Clemmensen reduction. Another one is Wolff-Kishner reduction. Sixth one is Grignard reagent. By using Grignard reagent, we can prepare the alkanes. That is, what is Grignard? Alkyl magnesium halide. We known as a Grignard reagent. By using this Grignard reagent, we can prepare the alkanes. This is also very, very important reaction for preparation of alkanes. These are the some important preparation methods of alkanes. First one is from alkenes and alkenes. Alkynes, double and triple bond, undergo reduction and in presence of hydrogen, nickel, platinum, palladium, they will form the alkanes. This reaction is also known as a Sabatier-Sanders reaction. From alkyl halide, undergo reduction, they will form the alkane. This is known as not having any name reaction. But also next one is Wurtz reaction. Wurtz reaction is very very important. By using alkyl halide in presence of sodium and dry ether, they will form the alkane. In cases of decarboxylation reaction, that is removal of decarboxylation, removal of carbon dioxide from acids. These are two methods. One is electrical method, chemical method. That is known as the electrical method is coal-based electrolysis. Chemical method is soda lime, sodium hydroxide, calcium oxide used. They will form the by removal of carbon dioxide. They will form the alkane. One more method from haldehydes and carbonyl compounds also can prepare the alkanes. So that is one is Clemmensen reduction. There are two types: Wolff-Kishner reduction. What are the reagents we used? How acidic medium and basic medium, how it converted to the alkanes. This is also we discussed. Next last one is Grignard reagent. By using alkyl magnesium halide, they will form the alkane. These are some of the important reactions for the preparation of alkanes. Then we discuss one by one how they prepare the alkanes by using different chemical and also named reactions. First we discuss about the from one by one. First we discuss from alkane and alkane. General methods of preparation of alkane. From first one is by using from alkenes and alkynes. These are known as unsaturated compounds. These are also known as a unsaturated compound used for the preparation of alkanes. From alkenes and alkynes. For example, alkene means CH2 double bond CH2. Alkyne means CH triple bond CH. This is undergo hydrogen means reduction by using catalyst nickel, palladium and platinum. Here also undergo hydrogenation nickel and palladium and platinum. Undergo reduction, they will form the CH3 single bond CH3. Here also there is directly they will convert it to alkane, methane. This reaction is also known as a Sabatier-Sanders reaction. This reaction is a Sabatier-Sanders reaction. This is a very important. If you take this is A, this is take B. Which will is the fast reaction in this case? You know, this is taken as two steps. First one converted to alkane, then other further converted to alkane. But this rate of reaction is B is greater than A. Why? Because this is, listen, I will explain. This is carbon is sp2 hydrogenized and trigonal planar. But in case of this is sp hybridized linear in shape. The attacking hydrogens, that is nickel is surface, it provides surface. These are the hydrogens. This is directly attacked to here. Here also the nickel, these are the catalyst. Nickel and palladium are the catalyst. We know these are the catalyst. They will directly this provide the hydrogens to this alkene. This is a same side addition, cis addition. These two are cis addition. Due to these hydrogens steric hindrance, this attacking to here is less probability. Rate of reaction is less, but it is easy to, there is no obstruction to hydrogens to attach in here. But in this case, these two hydrogens are hindrance. That's why the rate of reaction is, this alkyne is fast compared to alkene. These two cases, these are cis additions. This is a cis addition. This is addition of hydrogen, but the rate of reaction is B is greater than compared to A. This point, how it will, this is the nickel or palladium or platinum, whatever it may be, this surface area, they used for the catalyst for surface area, they deposited hydrogen, then attack to alkene in same side. This is known as cis addition. This you have to remember. Next, this is one of the preparation method. In this also discuss. If you take, for example, cis addition, you know the mechanism and all those things. Next, if you take, for example, this one. These are the two. By addition of hydrogen in case of nickel and palladium or platinum, whatever it may be. What is the addition of this hydrogen? This hydrogen is addition is syn addition. Means take hydrogen, this opposite to this. If methyl is thick line, these are daughter lines. If methyl is daughter line, those hydrogens are known as a hydrogens is a thick line, opposite to this methyl groups. These are the two possible forms for reduction of this hydrogen in case of dimethyl cyclohexene. In case this is having a plane of symmetry, that's why this is optically inactive. In two forms, two cases, this is having plane of symmetry, that's why this is having optically inactive. These two are optically inactive. This you have to remember. Next, we take unsymmetrical alkenes and symmetrical alkenes. This next we discussed about the symmetrical alkenes and unsymmetrical alkenes. Next we discuss about the symmetrical alkenes and unsymmetrical alkenes. For example, if you take, for example, phenyl C double bond C, this is ethyl group, and methyl CH3. This is a unsymmetrical alkene. This is cis form. If you take another one, trans form, CH2H5 CH3. This is trans form. This is cis form. This is trans form, cis form. How the for this is used for the how the optically enantiomers they from stereochemistry have to understand by using this alkane. This is very important. This undergo hydrogenation, which products will form? If you know, you write whatever they may be, as usually wherever is vacant position is, add that group hydrogen to this group. This carbon. These two write it. Either if write phenyl here and methyl here. Next, cis form. Phenyl here. These two write in straight line. If you write methyl here and methyl here, these two are vacant. Same. Next, other side. Write phenyl here, carbon C2H5. Here methyl. जहाँ जहाँ खाली है तो जहाँ जागा खाली है तो add hydrogen to that side. Where it is vacant, you write these two stretches like this, then you have to write it. These two groups in same cis form or trans form. Here the vacant is here, this way. Add hydrogens to this side. जहाँ जहाँ खाली है तो don't confuse, जहाँ जहाँ खाली है तो वहाँ add कर दो hydrogens. If it is here hydrogens, there is no plane of symmetry. Here also, this is also there is no plane of symmetry because here phenyl and here ethyl. Here also phenyl and here ethyl. This is optically active. This is also optically active. This is a cis form. These two are, what are the enantiomers? If it is non-superimposable, mirror images are known as the enantiomers. These two are non-superimposable, if you like this, but they are mirror images. That's why these are known as the enantiomers. These are known as the enantiomers. If in case of you take, these are unsymmetrical alkanes, not symmetrical. Symmetrical means same, but these are unsymmetrical alkanes. If you take similarly like this, by addition of hydrogen in presence of nickel and platinum or palladium, this nickel, platinum and palladium. If you write same like this, carbon, carbon, these two are stretching. One is phenyl, CH2, write here methyl, transform here methyl. Same similarly like this, carbon, carbon, this is phenyl, this is CH2H5. Other side you write methyl. This is, what is the condition? जहाँ जगह खाली है तो वहाँ add कर दो. Add that side. Wherever it is vacant, you have to add hydrogen to that side. Here is add. This is hydrogen. Here also hydrogen. Here also hydrogen. Transform. Here also hydrogen. These two also. This is also. There is no plane of symmetry. That's why this is also optically active. Chiral carbons. This is also optically active. There is no plane of symmetry. These two are also non-superimposable mirror images. That's why these are known as enantiomers. This is you have to remember. Very, very important. These are unsymmetrical alkanes. Either cis form or trans form, both are optically, they will form the active enantiomers. Next, we discuss about the symmetrical alkanes. Next, we discuss about the symmetrical alkanes. Reduction of symmetrical alkanes. Symmetrical alkanes. Similarly, like this, use the symmetrical alkanes. What are the symmetrical alkanes? Phenyl, C double one C. It is methyl. It is methyl. It is phenyl. This is the symmetrical alkanes. This is cis form. If you take, this is phenyl, this is methyl, here also phenyl, here is the methyl. This is the cis form, this is the trans form. For these two also use the hydrogenation. This is undergo hydrogenation in nickel or platinum. What will happen? Right, same like that. What is the formula? These two are stretching. You know that one. Phenyl, phenyl. You know. Phenyl, phenyl. What is the condition? Wherever it is vacant, add that position to hydrogen. Here it is, add 2 hydrogen. Here it is 2 hydrogen. Here it is hydrogen. Here it is. This is having plane of symmetry. That's why this is optically inactive. This is also optically inactive due to plane of symmetry. Cis form is optically inactive. There is no formation of enantiomers. But in this case, discuss phenyl, carbon, carbon. This is, what is this? This is also phenyl. Here methyl. Here methyl. Similarly, phenyl, carbon, phenyl. Here methyl. Here methyl. Wherever it is vacant, we add the hydrogen to that side. Here add hydrogen. Here add hydrogen. Here add hydrogen. Here it is hydrogen. This is not having plane of symmetry. No plane of symmetry. That's why this is optically active. These are also from the enantiomers. In symmetrical unsymmetrical alkenes, only cis form is optically inactive, remaining all are optically active. Those are formed the enantiomers. Enantiomers means non-superimposable minerals are known as enantiomers. Thank you. Next, these are some of the important to remember in case of hydrogenation of preparation of alkenes from by using hydrogenation in presence of nickel and palladium and platinum. Next, we discuss about the from alkyl halide. Second method is used for the preparation of from alkyl halide. Prepare the preparation of alkanes. Alkyl halide means R X is raised to hydrogen. This is also reduction. Reduction means alkyl is plus X is minus. Halogens. Halogens means either chlorine, bromine, iodine. These are the halogens are more electronegative compared to carbon. That's why this alkyl group get positive charge. X minus is negative charge. That will form the reduction. They will form the alkyl halide. What are the catalysts used here? Is these are very important catalyst. Catalyst one is next one zinc and dilute HCl. First one is zinc and dilute HCl. Reduction method. This is the reduction method. Next second one is next lithium aluminum hydride. Lithium aluminum H4. Third one is sodium borohydride. Fourth one is triphenyl tin hydride. Next fifth one is hydrogen iodide and red phosphorus. These are the reduction methods, reducing agent, catalyst, also reducing agent used for the preparation of from alkyl halide to alkanes. This is very important reactions. These are the very important reactions. These four are used for the release of H minus. These are the not the only these are release the H minus. If it is in this case alkyl plus, the H minus directly attached to here. Lithium aluminum hydride. This is negative charge. This is also negative BH4 minus. This is also release the H minus ions. These are the very important reducing agents to convert the from alkyl halide to alkanes. This HI and red phosphorus also used for the from preparation of alkanes by using alkyl halide. These are very important reactions. First, zinc and dilute HCl. Here I want to discuss. Zinc is the Zn plus 2. These are the very important reactions. Some of the points I will give you. Not required any mechanism more than like this. We will discuss later. Next, this is lithium aluminum hydride used primary and secondary alkyl halide to alkanes. Tertiary alkyl halide converted to alkanes. Primary alkyl halide means CH3, CH2, Cl. Secondary alkyl halide means we know that is secondary carbon. This is secondary. This carbon is primary. This carbon is secondary. If it is tertiary carbon halide means this is tertiary carbon. This is secondary. This is primary. These two are converted to alkanes means CH3, CH3 here CH3, CH2, CH3. But this is gives the lithium aluminum converted to alkane means CH3, C double bond CH2, CH3. They will form the alkanes, not alkanes. This is the very important to remember. This lithium aluminum hydride in presence of primary and secondary alkyl halide converted to alkanes, but tertiary alkyl halide is converted to alkane. This is very, very important. Sodium borohydride, primary and secondary, no reaction, only tertiary converted to alkane. This is very, very important because this is mild reducing agent, this is strong reducing agent, that's why this is converted. But in case of this one, triphenyl tin hydride, this is converted to all primary, secondary, tertiary to alkanes, alkyl halide to alkanes. This you have to remember. These are very, very important reducing agents. Just you have to remember. Lithium aluminate, sodium borate, triphenyl tin hydride. Next, HA and red phosphorus. This is converted to alkanes. This is also strong reducing agent. It is converted into HA used for the removal of phosphorus. Phosphorus is strong reducing agent. That's why phosphorus is used for this removal of hydrogen, iodine. Why? Because after formation of alkyl halide, after conversion, iodine again will do reversible reaction. That's why after completing this reduction, then iodine immediately removed from this reaction. That's why this is used for the preparation of alkanes by using alkyl halides. This is very, very, very important reactions too. Next method we discuss about the one of the important name reaction, that is Urju reaction. Very, very important to discuss about the Urju reaction. Third preparation method is named reaction is Urju reactions. What is this Urju reaction? This is alkyl halide. Means first we have to basic. This is alkyl halide in presence of dry ether converted to R dash plus 2NaCl. This is known as a Urju reaction. It is very, 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 very important reaction. For this reaction used for the ascent of carbon. Ascent means increasing of carbons. Means here one carbon is there, two carbons are there. If it is 2, 4, double ascent of carbon. This is used for the even number of carbons preparation of alkane. Even number of carbon alkanes. This is a very, very, very important reaction. This is used for Urju reaction. What is the mechanism of Urju reaction is, for example, if you take 2Na gives rise to, by removing 2 electrons, they will form 2Na plus. This is alkyl halide. Alkyl halide, what will happen? 2 alkyl halide, they dissociate from 2 alkyl radical. Alkyl halide, what will happen? 2 alkyl halide, after releasing electron, this is more electron, that's why take 2 electrons, it will get positive plus X minus. Here releasing 2 electrons gained by the 2 alkyl group, 2 alkyl radical, 2 alkyl plus, by taking 2 electrons, they will form 2 alkyl radicals. Then R radical plus R radical combining, they will form R dash R. If it is the same or different, whatever it may be. This is the mechanism for preparation of, this is a free radical mechanism. This is known as a free radical mechanism. This is known as a free radical mechanism. This is used very, very, very highly reactive. This is metal, that's why you use dry ether. Otherwise, if you use liquid like this, aqueous, it is highly explosive, easily catches the fire. That's why sodium metal is very highly reactive. That's why this is used for the dry ether. This is increasing the number of carbons. Next, even number of carbons will be more favorable for the reaction. This is very, very important reaction for Urju reaction. This is ascent of chain, carbon chain, and this is for best preparation method for preparation of alkanes by using this methods. Even number of carbons is preferable. Some of the discussion is, I will give you some of the examples. For example, what will happen if it is C2H5Cl plus you use the sodium gives rise to plus C2H5Cl in presence of dry ether. What will form? Cl C2H5. This is released, they will form C2H5 and C2H5. This is N-butane. Even number of carbon is more favorable than compared to odd number. That is, ascent of the chain also there. But what is the take mechanism? Here C2H5 radical plus C2H5 radical is there. They will combine it, they will form the, C2H5, C2H5. This is one of the no. Either if it is not like that, if it is not 100% yield, CH2 radical, CH3, CH2 radical. What will happen? Here it is CH2H, CH2 radical. If it is possible to the formation of this releasing this break this hydrogen, they will form hydrogen radical. The hydrogen radical attack to here. What will form? Here they will form here CH2 radical CH2. There is alkene plus this three radical converted to here. They will form ethane. This is alkene. Also the alkane ethane. Two carbons are. These are also the side products they will form in the reaction. That's why 100% yield is not possible in this case. 100% yield is not. Even number of carbons is more favorable, and also the formation of these products, side products, ethane and alkene. But most of the percentages they will form the butane only. Next, this is you have to remember, because there is a possibility of formation of these products also, but most of the 90% of formation of this one only. By using this Wurtz reaction, you can number of reactions we can try it. This is very important. And also the many named reactions, intermolecular, many things are there. By using different reactions, one is Frank-Land reaction, same Wurtz but somewhat different. Frank-Land reaction. I will give you some of the named reaction based on the Wurtz. Next one is fitting reaction. Same similar mechanism. Fitting reactions. Next one is Wurtz fitting reaction. Wurtz fitting reaction. Next one is Ullmann synthesis. Ullmann's synthesis. Ullmann synthesis. Frank-Land reactions. In case of same alkyl halide, methyl chloride, but you use the zinc in place of sodium. You can use the zinc. Same preparation of this CH3, but you can in this case use the zinc dead answer. That is known as the Frank-Land reaction. Fitting reaction is use the phenyl rings. Chloride, sodium. This is known as a fitting reaction. Two phenyl groups. This is the fitting reactions. One is alkyl halide, another one is same sodium. You can use sodium, but here also sodium. But fitting means two phenyl groups. Wurtz fitting means one is alkane and another one is Wurtz. This is the methyl group. Wurtz fitting reaction. Frank-Land reaction is zinc. Fitting means two phenyl groups. Wurtz fitting means one phenyl on one methyl group. This is the one other preparation. Ullmann means copper and heat. This is the iodide. Use the like this. Biphenyls. Bisphenyls you can prepare. This is the Ullmann synthesis. These are some of the new reactions. Frank-Land reactions, fitting reactions, Wurtz fitting, Ullmann synthesis. This is one of the important to remember reactions. Next, we discuss about the very important decarboxylation reaction. Very important. These are the decarboxylation reactions. Next, we have to discuss about the decarboxylation reactions. Decarboxylation reactions. Here, what are the decarboxylation reactions? Means removal of carbon dioxide. Removal of carbon dioxide from acids. These are the two types of reaction. Removal of carbon dioxide means that is carboxylic acids by removing this minus CO2 they will form the RH. Here also RH. Here this coal-based electrolysis. Coal-based electrolysis. One of the method is coal-based electrolysis. Means if you use sodium hydroxide by using sodium hydroxide strong base, then in presence of water, water, they will form the alkane. This is known as the electrical method. Coal-based electrolysis. This is known as an electrical method. Second one is sodium hydroxide and in presence of calcium oxide, quicklime, they will form the alkane. This is chemical method. This is known as a soda lime method. Soda lime method. These two methods are used for the preparation of alkane, RH. This is the decarboxylation reactions. Very important. First we discuss about the coal-based electrolysis mechanism. Also discuss. Then after discuss. If you take, for example, that is coal-based electrolysis. Coal-based electrolysis method. What is coal-based electrolysis method? If you take, for example, acid, any acid, RC double bond OH in presence of base sodium hydroxide in presence of water, they will form the alkane R double bond R plus CO2 plus what will form carbon dioxide plus they release the hydrogen. This is the preparation method for alkane coal-based electrolysis. This is the electrolysis method. What is the mechanism? First, you have to remember mechanism. Here we know RC double bond OH. This is the weak acid. All organic acids are weak acids. This is sodium hydroxide. This is strong base. This is the strong base, we know. By reacting strong base with this acid, they will form the salt. Acid plus base reaction is known as they will form the salt. Salt, what is salt? O minus Na plus sodium acetate salt. They will form the RCO minus Na plus sodium acetate salt will form. And also they release the water. This is the, they will form the water release, they will form. This is the strong salt. This salt will be electrolyzed. What will happen? RCO minus Na plus. First at anode. What will happen at anode? The electrolysis method. At anode, oxidation will be formed. If you take RC double bond O minus in presence of 2, take, what will happen? At anode, oxidation. This is negative charge means 2 electrons. By releasing 2 electrons, they will form RC double bond O radical. O radical will form. 2 electrons will be released. This RC double bond O, they will form O radical. This release the 2 electrons. 2. This radical is here. Next, this is also released to a radical. This radical, they will form the carbon dioxide bond. They will form here two alkyl radical, means this is radical, one of the, this is also bond, means two electrons. This electron will be shared by this one. This is also, here also one more electron is there, they will form the pi bond. Here we get the single bond, R dot bond. They release the, this is known as C double bond carbon dioxide. The alkyl radical will form R dash R. What will happen? R radical plus R radical will form R. This is known as an alkane. At anode, alkane will be formed. At cathode, what will happen? At cathode, what will happen? At cathode, what will happen? At cathode, here, water is there. Water undergoes H plus and OH minus ions. Water dissociate, they will form H plus plus OH minus ions. Here and Na plus is also their solution. This is H plus at cathode. At anode, oxidation. We know, we have to remember. At anode, oxidation. At cathode means negative charge. That's why this is reduction. Undergo reduction means by 2H plus, by taking, here we release the 2 electrons. By taking these 2 electrons, they will release the hydrogen. But anode is oxidation. By anode, oxidation means release of electrons. Cathode means reduction, means taking of electrons. They release the hydrogen. At anode, they will form the alkane. At cathode, the hydrogen reaction. In solution, what will have remaining? In solution, Na plus OH minus is remaining. They combine, they will form 2 NaOH, sodium hydroxide. Sodium hydroxide is a base. Sodium hydroxide is a basic. Remaining solution, base. That's why if the reaction going on, the basic nature is increases. The coal-based electrolysis and decarboxylation, the solution is basic in nature. At anode, alkane. At cathode, hydrogen released. The solution, in the solution remaining is sodium hydroxide. This is the basic in nature. This is also used for the preparation of even number of symmetrical alkenes. This is even number of alkenes is more favorable. This is also symmetrical alkenes. Symmetrical alkenes. And this is the basic in nature. Solution is basic in nature. This is methane cannot be prepared. CH4 cannot be prepared because here if you take methane, what if from these groups will form, means ethane will form. Methane cannot be prepared by using this reaction. This is about the coal-based electrolysis. Very important reaction to remember this one, coal-based electrolysis method. This is very important decarboxylation of iron. In this case, coal-based electrolysis, we remember one more name, coal-based electrolysis method. Coal-based electrolysis method, methane CH4 cannot be prepared. Cannot be prepared. Some of the point. One. Next, even number of carbons and symmetrical alkanes formed. Third one is solution is basic, means pH increases. pH increases. These are the points we have to remember in case of coal-based electrolysis. Very important. In this, one more next reaction is this is used for the preparation of alkenes and alkynes also. How the coal-based electrolysis is. If you take for example, decarboxylation reactions used for the preparation of alkenes. For example, if you take, what will happen? Some of the reactions. If you take this one, C double bond O in near whatever it will be H. Definitely 2 moles only in presence of sodium hydroxide plus water. What is the, how will it form? We know these two reactions alone. Here it will form the radical. to this is the reaction. It will form the product. Same similar like that we can give any reaction, we can form the alkanes. Next we have one more method is to explain, that is soda lime method. We know second method in this case decarboxylation is soda lime method. Soda lime method. What is the reagent used here? Sodium hydroxide plus calcium oxide, they will form the alkanes. For example, if you take RC double bond O OH, they will form the, in presence of sodium hydroxide and calcium oxide quicklime, they will form the alkane by releasing this one. This is the soda lime method, that is the decarboxylation method. Here in that case ascent quite different. Here descent of carbon, one of the carbon is decreases, descent of carbon chain. Here ascent of carbon chain, number of carbons is increases. Here descent of carbon chain. This is very very important. Means if you take this is the descent of carbon chain, means one of the carbon here released by using carbon dioxide, that's why this is descent of carbon. For example, if you take benzene ring, if you take this one COONA plus NaOH, what will happen in terms of calcium oxide by heat? They will form, this is what will form? They will form, this is Na2CO3. They will form Na2CO3. This hydrogen gets come to here. They will form the benzene. Sodium salt of benzoate, in terms of sodium hydroxide, calcium oxide and hydrogen, they will release the Na2CO3, Na2O3 plus C. That's why they will form the benzene by releasing the Na2CO3. CO3 released in the form of CO2 released, but they are in the form of sodium carbonate. That's why they will form the benzene. This is used for the soda lime method, used for the descent of carbon chain. One of the carbon is decreases in this case. For example, if you take, for example, rate mechanism we discussed, this is also have to important to rate of the reaction. They will form, what will happen? RCOONA in presence of sodium hydroxide basic medium. What will form the heat basic medium? They will form this one. They will form C double bond O minus. They will form Na plus. After this is next step is C double bond O minus. O minus release here. Then it will get the alkyl group. That's why they will form alkyl minus plus CO2 released. This is the rate determining step. Formation of carbene ion is the rate determining step for the, in this, the stability of carbon ion, we know primary is greater than secondary is greater than tertiary. This you have to run. But in case of free radical and carbocation, the stability is secondary is greater than tertiary is greater than primary. But in case of carbene ion, the stability is primary is greater than secondary is greater than tertiary. This is the formation of carbene ion is the rate determining step. That's why they, if you in case of after that R minus in the solution, they will get the H plus. They will form the alkane. This is the preparation method of alkanes by using decarboxylation, by using soda lime method. This is very two methods. One is coal based electrolysis. This is soda lime method. Soda lime method is number of carbon, descent of the carbons, but in coal based electrolysis, ascent of the carbons. Next preparation method is very important. That is next preparation method is very important, is from carbonyl compounds. These are the very important. These are also very important. From carbonyl compounds. Carbonyl compounds. What are the carbonyl compounds? These are known as carbonyl compounds. Means one is all aldehyde, another one is ketone. This is aldehyde, this is ketone, aldehyde and ketone. Upon reduction, they will form the alkane or CH3 or CH2R or CH2 hydrogen. These are the, what are the reduction methods? These are the two reduction methods. First one is, there are two reduction methods. One is Wolff-Kishner reduction. First one is Clemmensen reduction. Write it. First one, Clemmensen reaction. Second one is Wolff-Kishner reduction. Wolff-Kishner reduction. These two are the reduction methods used for the preparation of alkanes by using Clemmensen carbonyl compounds. Clemmensen reduction is catalyst is zinc amalgam and HCl is used for the Clemmensen reduction. But in case of Wolff-Kishner reduction, NH2 hydrogen, this is acidic medium, in presence of NaOH base used for the preparation of alkanes by using carbonyl compounds. This is a Wolff-Kishner reduction. This is a Clemmensen reduction. These are the this is Clemmensen reduction. This is Wolff-Kishner reduction. These are the reduction methods used for the preparation of alkanes. Very, very important. Next, discuss about the one by one mechanism. Next, possible mechanisms. Wolff-Kishner, first Clemmensen reduction. What will happen Clemmensen reduction? Clemmensen reduction mechanism. Discuss about the mechanism. Clemmensen reduction mechanism. If we take for example RC double bond O R R dash. This is the in Clemmensen reduction catalyst is zinc amalgam and usually the concentration of HCl. What will happen in this case? If it is the oxygen is more electronegative, carbon is less electronegative, it will release the negative charge to here. They will form mechanism. Here you get the positive charge, here you get the minus, here R dash. Zinc release the zinc undergo oxidation, they will form Zn plus 2 plus 2 electrons. These 2 electrons related to this vacant positive charge carbocation, they will form R dash, negative charge here O minus. We know HCl on dissociation they will form H plus plus Cl minus. This H plus is donated to here and also here. Next what will form? R dash, here we get the hydrogen, here we get the OH. This is here in zinc plus H plus is there. This is lone pair. The lone pair donate to H plus. They will form. Here we get the positive charge. What will happen? This is R dash hydrogen. Here H2O plus after getting. By donating these 2 electrons here, they release the water molecule. They will form. Here again we get the positive charge and hydrogen. Positive charge. The zinc already having 2 electrons. Again it donate electrons, 2 electrons to here. They will form here negative charge and hydrogen. By donating H plus to here, by taking 2 electrons here. By donating H plus, they will form the CH R dash. This is the alkane used for the preparation of Clemmensen reduction. This is the mechanism. Have to remember. This is very, very, very important reaction. in case of carbonyl compounds. Next, we discuss about the Wolff-Kishner reduction mechanism. Wolff-Kishner reduction. Wolff-Kishner reduction. What is Wolff-Kishner reduction? We know R C double bond O R dash in presence of hydrogen NH2 NH2. This is acidic medium. This is a basic medium. This is used for the basic medium. Base either sodium hydroxide, whatever basic medium. This is NH2 hydrogen and presence of basic medium, any base sodium hydroxide. Okay, no problem. What will happen here? This is, we know, write it another way. R C double bond O R dash plus H2 hydrogen and NH2. This release the water. They will form the RCR dash by removing of water mechanism C double bond N NH2. We know the base OH minus. This take the hydrogen from here. They release the water. They will form the here NH minus. RCR dash double bond N NH minus. This is negative charge donated here. This gets the negative charge. What will happen? RCR dash here you get the negative charge N double bond NH. Here negative charge is there. This is take the H plus, the solution, that's why they have them H plus ions. They take the H plus, they will RCR dash H N double bond NH. Again OH minus ion base take the hydrogen from here. Again we get the negative charge here. What will happen? RCR dash, already hydrogen is there, N. After releasing this one, this here release the nitrogen. Here also one more gets the negative charge. By taking H plus, again it converted to RCR dash. This is the alkane. This is the mechanism for Wolff-Kishner reduction. There is the release of hydrogen and also the water. Release the nitrogen because by taking the negative charge, then shifted this hydrogen, they will form the alkane. This is the Wolff-Kishner reaction. This is a basic medium, that is a acidic medium. Must you have to remember. Very, very important reactions, these two, by using carbonyl compound method. Next, we discuss about the one more method. Next, in this also carbonyl compound. So we know red phosphorus and HI. This is a very strong reducing agent. Strong reducing agent. This is very, very strong reducing agent. It reduces anything. C double bond acids. Next, acid chlorides. Next, acid amides, aldehydes, ketones, alkyl halides. These are all converted in terms of HI and red phosphorus to alkanes. Very, very important. Now to remember, this is any compound, it is converted in presence of red phosphorus and HI, they will convert it to alkane. This is very, very, very important. Strong reducing agent. This is red phosphorus and hydrogen iodide. Next, we discuss about the Grignard's reagent. This is very, very important. Last one is used for preparation of metals. Grignard's reagent. Grignard's reagent. Grignard reagent. What is meant by Grignard reagent? This is known as a alkyl magnesium halide. Is known as a Grignard's reagent. This is used for very, very important. This is how to prepare Grignard methyl bromide in presence of magnesium, use the dry ether, they will form the methyl magnesium halide. This is an organometallic compound. How it will formed? This is ethyl bromide, means this is methyl plus bromine minus. It is react. What will happen? Next, Br minus. If you take in case of magnesium plus radical, this is used for the preparation magnesium, methyl magnesium halide will form. This is having with after magnesium is delta plus, is delta minus. This is also a delta minus. This is the charge. This is acts as a nucleophile. Nucleophile. This is acts as a nucleophile. This is used for the very important base. If you take methyl magnesium halide in terms of any either water, either any H plus donating group, whatever it may be, H plus donating group, either H2O water or next NH2 ammonia, next whatever it may be, either acidic acetylene. These are really the H plus ions easily. NH3 also provides the H plus ions easily. Water also provides H plus ions easily. Bases, they will form immediately methane. Here CH minus is there. That's why they take the H plus from any acid donating group. They will form the alkane, methane. This is best method for used for the preparation of alkanes. This is best method for preparation of alkanes. In water, whatever it may be, if you take H plus, they will form immediately methane. If you take for example HCl, this is H plus donating here, they will form methane magnesium dichloride. Like this they will form. That is, if you take for example, this is used for the preparation of method for preparation of alkanes. Grignard reagent. By using Grignard reagent, you will form it. Next one, last method is Corey-House synthesis. Corey-House synthesis. What is the name? This is dialkyl copper lithium. Must remember, this is the method. Dialkyl copper lithium is alkyl, copper and lithium. Li plus dialkyl copper lithium. This is used for the preparation of cuprate. Dialkyl cupric lithium lithate. That is used for the preparation of alkanes. This is what is the preparation method for this one is, if you take alkyl copper R dash lithium in place of methyl magnesium bromide, whatever it may be, if you use alkyl halide any CH3 CH2 Br, what will happen? This provide the alkyl group to here, they will release the bromine from here, they will form alkyl copper lithium and here bromine. These two are alkane, CH3 CH2 R dash. This is the alkane. This is from the alkane. This reagent will provide the alkyl group to any alkyl halide. They will form the alkane. This is very important method. This is also ascent of chain, means number of carbons increases. This is also ascent of carbon chain, means number of carbons increases. This is from the ascent to reactions, means nucleophilic substitution. This nucleophile come to attack here, this nucleophile comes out. That is substitution of one nucleophile to another. That is nucleophilic substitution reaction. This is Corey-House synthesis. This is reagent used for the preparation of alkanes. This is number of carbon chain increases, means that is ascent, increasing of the carbon chain. This is the best method to prepare any alkanes, either odd or even, whatever it may be, but this is number of carbon chain increases. These are the some of the important methods to discuss up to now is the preparation of alkanes. This is very important methods to preparation of alkanes. Next class we will discuss about the properties of alkanes. Thank you students.